Right now, I mean, at this exact second, a subatomic particle sitting inside a vacuum chamber in a laboratory in New York is instantaneously reacting to the state of another particle.
Right.
And this other particle is located in a galaxy 3 million light years away. There's no signal passing between them. No light is traveling across the void to deliver a message.
Which is wild. I mean, to Albert Einstein, this was strictly impossible. He famously, he derided it as spooky action at a distance.
Yeah, spooky action. But a 2,000-year-old Buddhist text not only predicted this exact phenomenon, it actually built an entire, comprehensive map of the universe around it.
It really is an incredible convergence.
Yeah.
We are looking at a situation where the absolute bleeding edge of theoretical physics is mathematically verifying a spiritual cosmology that was written down before the fall of the Roman Empire.
Which is just mind-blowing. And that is our mission for this deep dive. If you are joining us today, you are going to want to settle in. We are taking a massive stack of sources and unpacking this profound realization that our everyday sense of separation is an illusion.
Yeah, totally. Like this deeply ingrained belief that you, me, and the objects around us are isolated, independent things. It's a complete surface-level illusion. Reality isn't made of things. It is made of unbroken relationships.
And the sourcing we have to support this is extraordinarily dense. It's really wide-ranging. I mean, we are pulling directly from classical Mahayana Buddhist scriptures, specifically the Buddhāvataṃsaka Sūtra.
Right.
And we are pairing that ancient wisdom with modern peer-reviewed physics papers detailing relational quantum mechanics and the highly mathematical framework of relational quantum dynamics.
We are also digging into some really fascinating historical correspondence. The private letters exchanged between the pioneering psychologist Carl Jung and the Nobel laureate physicist Wolfgang Pauli.
Such a strange but brilliant pairing.
Exactly. And, well, because we want to see how these mind-bending concepts are actively debated right now, we're going to parse through some incredibly spirited, highly technical arguments from Reddit's Ask Physics community. Yeah, those Reddit threads get intense. But to navigate this sheer volume of information, we really need a conceptual anchor. So the defining visual for everything we discussed today is the classical Buddhist metaphor of Indra's net.
The cosmic web.
Exactly.
Yeah.
Our objective is to take this image of a vast, infinite cosmic web where every intersection holds a jewel that perfectly reflects all the other jewels in existence and bridge it directly to the demonstrable physical reality of quantum entanglement.
Okay, let's unpack this, because before we dive into the quantum equations that prove independent objects don't exist, we need to trace the architecture of the illusion itself.
Right, the origin story.
Yeah. Where does the actual concept of Indra's net come from? I assume it wasn't just, invented by quantum physicists looking for a cool metaphor.
Oh, far from it. The genealogy of Indra's net is actually quite violent in its origins, strangely enough.
Really?
Yeah, if you look at the early Vedic period in India, going back around 1000 BCE, you find the first mentions of it in the Atharvaveda. And in that specific historical context, the net wasn't a peaceful metaphor for cosmic harmony at all. It was a literal weapon of war.
Wait, a weapon? Like a gladiator's net?
Exactly like that, but on a cosmic scale.
Yeah.
It was wielded by the primary storm deity, Indra. The text described Indra casting this massive net down from the heavens to physically trap, entangle and paralyze his enemies in battle.
Wow.
Yeah, it's a symbol of the inescapable absolute power of the gods over the forces of chaos. If you were caught in the net, your fate was sealed by the overarching structure of the cosmos.
That is a stark contrast to how the metaphor is used later. I mean, going from a divine weapon of mass entanglement to a philosophical symbol for the interconnected beauty of reality is quite the leap.
It's a huge leap. The shift took several centuries, though. The transformation we recognize today really crystallized between the 3rd and 4th centuries CE, when Mahayana Buddhism absorbed the imagery and radically reinterpreted it.
Right, that's where the sutras come in.
Exactly. The most vivid, expansive description of this new vision appears in the Buddhāvataṃsaka Sūtra, which is often translated as the Flower Garland Sutra.
The narrative in the sutra focuses on a young pilgrim, right? A guy named Sudhana.
Yes, Sudhana.
He is traversing the cosmos on a quest for ultimate enlightenment, and he eventually encounters the Bodhisattva Maitreya. And Maitreya essentially serves as a guide to the ultimate nature of reality, leading Sudhana into a vast, expansive tower.
And it is inside this tower that Sudhana experiences the pure, unadulterated vision of Indra's net. The visual description provided in the text is mathematically staggering, even by today's standards.
It really is.
The sutra asks you to imagine a net that stretches infinitely in all spatial dimensions. It has no edges, no boundaries, no top, and no bottom.
Just going on forever.
Right. And at every single node, every intersection where the threads of the cosmic net cross, there hangs a brilliantly polished jewel.
And because the net is infinite in dimension, that inherently means the jewels are infinite in number. But it is the optical property of these jewels that makes the metaphor so enduring, I think.
Oh, absolutely.
The text states that every single jewel is perfectly clear and highly polished. So if you look closely at one specific jewel, you don't just see the jewel itself. You see it perfectly reflecting every other infinite jewel in the entire net.
It becomes an infinite recursive loop, because if jewel A is reflecting jewel B, and jewel B is reflecting jewel C, then within the reflection of jewel B inside jewel A, you also see the reflection of jewel C.
It's like a fractal.
Yes. You're looking at a holographic matrix. Every single part contains the entirety of the whole.
I understand the poetry of it, definitely. But I have to push back a little on the mechanics of this metaphor.
Okay, let's hear.
Let's say I'm standing in a giant, perfectly spherical hall of mirrors. I look into one mirror, and I see an endless tunnel of reflections bouncing back and forth. But in that physical scenario, I am the object being reflected.
Right, there's a you.
There is a physical, independent substance, which is me, standing in the room. If in Indra's net, every jewel is simply a reflection of all the other jewels, and those jewels are just reflections of the others, well, where is the actual substance?
Ah, the missing core.
Exactly. What is generating the image if everything is just a reflection of a reflection?
I love this question. Because the absence of a central, independent substance isn't a flaw in the metaphor. It is the entire point of Hawaiian Buddhist philosophy.
Really?
Yeah. To address your pushback, we have to look at the philosophical engines driving this worldview, the concepts of shunyata and pratityasamutpada.
Okay, so shunyata usually translates to emptiness, which to a Western ear sounds synonymous with a void or a vacuum, just nothingness.
Right, and what's fascinating here is that the Western interpretation of emptiness is almost entirely backward in this context.
Backward how?
Shunyata does not mean a dark, nihilistic vacuum. It means that entities are empty of an independent, isolated, inherent self-nature. The jewel has no core identity that exists in isolation.
So the jewel doesn't possess a kind of jewelness that exists on its own, completely separate from the net.
Precisely. And this is where pratityasamutpada, or dependent origination, comes in. It is the doctrine that all phenomena arise strictly in dependence upon other phenomena.
So they need each other to exist.
Yes. A node in Indra's net only exists because of its intersection with the other threads. Its entire identity, its entire form, is constructed exclusively by its relational reflections.
Wow.
If you remove the rest of the net, the individual jewel doesn't just sit there alone in the dark. It ceases to exist entirely.
There is a fantastic synthesis of this in the sources from the philosopher Alan Watts. He tackled this concept of relational identity by asking his audience to think about a tree.
Oh, the tree analogy is perfect here.
Yeah, we are conditioned to point at an oak tree and say, that is a tree, it is a discrete, separate object. But Watts points out the absurdity of that. Yeah. He asks, can you mechanically separate the tree from the sunlight that drives its photosynthesis?
No, you can't.
Can you separate it from the microbial life in the soil that processes its nutrients, or the gravity that dictates the downward growth of its roots? If you somehow strip away the sunlight, the dirt, the water, and the gravity, the thing we call a tree vanishes.
It's gone.
It isn't a separate object interacting with an environment. It is an expression of the environment.
Watts was brilliant at scaling that logic up to human consciousness, too. I mean, we experience the world from behind our eyes, feeling like autonomous egos locked inside a bag of skin.
Like we're just pilots in a meat suit.
Yeah, we feel like we are placed into the universe. But if you apply the logic of Indra's net, a human being is not an isolated entity interacting with the cosmos. A human is an activity of the cosmos.
That's a profound shift.
Just as a whirlpool is not a separate object sitting on top of a river, but rather a dynamic pattern that the river is doing. You are a dynamic pattern that the universe is doing.
We are a localized behavior of the entire system. But from a strict logical standpoint, that creates a massive headache.
True.
How can I be uniquely myself, occupying this specific chair right now, but also be constituted entirely by everything else in the universe? It feels like a logical paradox.
It is a paradox if you rely strictly on classical Aristotelian logic, which is highly binary. In classical logic, a statement cannot be both true and false. An object cannot be A and not A simultaneously.
Right. The law of non-contradiction.
Exactly. But modern logicians like Graham Priest have looked at structures like Indra's net and applied a framework known as dialetheism.
Dialetheism is the idea that certain contradictions are genuinely true, right?
Yes. Dialetheism argues that there are true contradictions, known as dialetheas. When you analyze a jewel in Indra's net, you find a perfect logical dialethea.
How so?
The jewel is entirely its own unique focal point. It is a specific set of coordinates in the net. It is itself. Yet simultaneously, because its properties are derived entirely from reflecting everything else, it is not itself. It is the rest of the universe.
It's both at once.
Yeah, it is a formal way of representing a non-dual reality. Identity is purely interdependent.
Think about what that actually implies for you as a listener. When you conceptualize your own identity, how much of you is a hard, isolated core, and how much is a complex reflection of your genetic ancestry, the language you were taught, the subtle cultural cues of your environment, and the friends you interact with daily?
It's all reflections.
If you somehow stripped away every single relationship you have with the outside world, there wouldn't be a pure, isolated you left behind. According to the architecture of Indra's net, the universe is a vast network of relations, and you are simply what the whole network looks like from one specific shining node.
It is an incredibly beautiful ontological framework. But if we stopped here, this would just be a philosophical discussion.
Right.
The reason this deep dive exists is because the claims made by this ancient sutra that isolated, independent objects are a total illusion are no longer just the domain of mystics.
No, they are not. For centuries, Western science operated on the exact opposite assumption. We built our entire civilization on the belief that reality is made of separate, discrete things.
Things bumping into things.
Yes. But that classical view is completely disintegrating. Let's shift gears and look at the breakdown of the classical world and how quantum physics was forced to reinvent Indra's net.
To understand the magnitude of this shift, we have to look at what quantum mechanics actually replaced. For hundreds of years, the Cartesian and Newtonian models dominated science.
The clockwork universe.
Right. This worldview treated the universe as a highly complex, but fundamentally predictable, clockwork mechanism.
And machines are built out of individual parts. The assumption was that if you zoom in far enough, you will eventually find the ultimate indivisible building blocks of reality.
Tiny, hard, solid little billiard balls of matter interacting on a spatial table. We call them atoms.
In that classical model, things only interact locally. If billiard ball A wants to affect billiard ball B, it has to physically cross the space between them and bump into it.
Or it has to emit a local force, like an electromagnetic field, that travels across space at a finite speed to exert influence. Everything is bounded. Everything is local.
But the deeper physicists looked, the more the billiard balls started to look like ghosts. We aren't going to spend time rehashing basic quantum mechanics here. If you are listening to this, you likely already know that the solid particles dissolved into probability waves.
The weirdness of the quantum realm.
Yeah, you know about superposition, where a particle like a photon doesn't have a fixed, definite state, like its spin or polarization, until it is measured by a macroscopic system.
But the implications of that probabilistic nature terrified the old guard of physics, Albert Einstein chief among them. Einstein believed in local realism.
He hated the randomness.
He really did. He believed that particles had to have definite properties whether we measured them or not, and he believed that no influence could ever travel faster than the speed of light.
Right. So in 1935, Einstein, along with Boris Podolsky and Nathan Rosen, published the EPR paradox paper.
A very famous paper.
They essentially said, if quantum mechanics is a complete theory, then it allows for something totally absurd. Two particles acting as one, regardless of the distance between them. They thought exposing this absurdity would prove quantum mechanics was missing something.
They were trying to prove the existence of hidden variables. The idea that the particles actually do have secret, pre-programmed instructions that we just can't see yet.
But history proved Einstein wrong. The absurdity he feared is actually the foundational truth of reality. Entanglement is real.
Let's mechanically unpack how this non-locality functions, because it is the empirical proof that independent objects don't exist.
Okay, let's do it.
Imagine a laboratory setup where we generate a pair of entangled photons. We'll call them alpha and beta. Because they are born from the same quantum event, their mathematical descriptions are inextricably linked.
They are a pair.
Right. So we capture beta, and we fire alpha through a vacuum tube aimed at a detector on the moon.
So we have a massive spatial gap. According to the Copenhagen interpretation, while alpha is traveling to the moon, neither photon has a fixed spin. They exist in a superposition of all possible complementary states.
Correct. But the moment the detector on the moon intercepts and measures alpha, forcing it to choose a definite state, say a vertical spin, the superposition collapses.
Instantly.
Yes, at that exact indivisible fraction of a second, the state of beta, sitting back in the lab on Earth, is instantaneously determined. If alpha is vertical, beta becomes horizontal.
Here's where it gets really interesting, but also incredibly confusing. If beta is on Earth and alpha is on the moon, there's a distance of nearly 400,000 kilometers between them.
That's a lot of space.
Light takes over a second to travel that distance. How can beta instantly know to take the opposite state if no signal, not even light, has had time to travel back from the moon? Isn't that magic? I mean, isn't that a blatant violation of relativity?
This is exactly what Einstein meant by spooky action at a distance. To explain how this works, we have to look at Bell's theorem, proposed by physicist John Stuart Bell in 1964.
What did Bell figure out?
Bell came up with a brilliant mathematical inequality to test whether Einstein's hidden variables were true or if quantum mechanics' dynamic instantaneous correlation was true.
The analogies used to explain Bell's theorem usually involve people holding different colored socks or gloves, but those analogies fall apart because they rely on classical physics.
They're too simple.
Exactly. Let's use a better mechanism from the sources. Imagine a cosmic casino.
I love this one. A cosmic casino is a much better framework for understanding the violation of Bell's inequalities.
So in this casino, we have two slot machines. One is on Earth and one is on the moon. These machines don't take coins. They just spit out a random result, a cherry or a bell, every time you pull the lever.
Okay.
But these machines also have 3 different settings. Setting 1, setting 2, and setting 3.
And those settings represent the different axes along which we can measure the spin of a photon.
Right. Now, Alice is on Earth and Bob is on the moon. They pull the levers on their respective machines at the exact same time. If they both happen to have their machines on the same setting, say setting 1, the machines always give opposite results.
Always. If Alice gets a cherry, Bob gets a bell. Every single time.
So if Einstein's local realism were true, the only way the machines could guarantee opposite results when the settings match is if they had a hidden computer chip inside, pre-programmed before they were separated.
Like a secret instruction manual.
Yeah. The chip says, if setting 1, display cherry. If setting 2, display bell.
Exactly. So Bell said, let's test the pre-programmed theory. Alice and Bob randomly change their settings for every pull. Sometimes Alice uses setting 1 and Bob uses 3. Sometimes Alice uses 2 and Bob uses 1.
They mix it up, right.
Bell calculated that if the machines were secretly following pre-programmed instructions, those hidden variables, then when Alice and Bob use different settings, their results should match at least 33% of the time.
That's the inequality limit.
Yes, that is the inequality limit. It's pure statistical probability based on local realism.
But when physicists actually run this experiment with entangled particles, they don't get a 33% match. They get a match only 25% of the time. The statistics physically violate Bell's inequality.
Which is huge.
It really is. The fact that the physical universe violates that 33% limit proves, beyond a shadow of a doubt, that there are no hidden computer chips. The particles do not possess pre-existing instructions. Their states are not decided before they are measured.
Which leaves us with a terrifying, beautiful reality. When Alice pulls the lever on Earth, the universe is dynamically deciding the outcome for both machines at that exact instantaneous moment.
But wait, how does the Earth machine influence the Moon machine without sending a signal through the space between them?
It doesn't.
It doesn't.
No, the question itself is flawed.
Okay, if we connect this to the bigger picture, the reason no signal has to travel through space is that, mathematically and ontologically, alpha and beta are not two separate things. They are a single, undivided quantum system that happens to be smeared across 400,000 kilometers of what we perceive as space. The separation is an illusion.
It's totally an illusion.
Alpha's identity does not exist in isolation. It is defined entirely by its relational correlation to beta.
It is the physical manifestation of Indra's net. The individual jewel has no inherent state. Its state is strictly a reflection of the rest of the net. Entanglement proves that at the fundamental level of reality, things do not have properties. relationships have properties.
That shift from things to relationships requires a massive restructuring of how we do physics. We are moving past the breakdown of the classical world into the active theories that are trying to bridge the math of the quantum realm with this ancient relational ontology.
And the primary theoretical framework leading this charge is relational quantum mechanics, or RQM, which was heavily developed by the physicist Carlo Rovelli in the 1990s.
Rovelli's work is fascinating.
It really is. Rovelli looked at the paradoxes of quantum mechanics and realized that the contradictions only arise because we cling to the idea of an absolute, observer-independent reality.
Rovelli argued that we have to abandon the idea of a view from nowhere. In classical physics, a star exists and its properties are absolute, whether anyone is looking at it or not.
But RQM argues that in the quantum realm, a system only possesses physical properties relative to a specific interaction with another system.
Let's unpack the mechanics of RQM. Rovelli asserts that you cannot ask, what is the absolute state of this photon? You can only ask, what is the state of this photon relative to the detector measuring it?
Right. If observer A measures a system, the system assumes a definite state relative to observer A. But relative to observer B, who hasn't interacted with observer A yet, the system and observer A are both still in a superposition.
Wait, so if observer A and observer B don't interact, do they not share the same universe? Does RQM imply we all live in separate subjective bubbles?
No, they share the same physical universe, but their descriptions of reality are uniquely contextual. There is no master spreadsheet containing the true state of everything. Reality is entirely composed of the interactions themselves.
The sources provide a great analogy here. Imagine trying to put together a massive jigsaw puzzle.
Ah, the puzzle analogy.
Yeah, but every time you pick up a piece, its edges shift slightly depending on which piece you try to connect it to. If you look at any single piece locally, the image on it makes sense.
Right.
But you can never step back and see a single predetermined objective photograph of the finished puzzle because the global picture doesn't exist independently of the connections. Reality is the network of relations.
This relational focus actually has deep roots in the particle physics of the 1970s. Long before RQM was formalized, physicist Fritjof Capra popularized a concept known as the Hadron bootstrap model.
Right. Capra wrote The Tao of Physics, which was one of the first mainstream texts to explicitly link Eastern mysticism and quantum mechanics. The Hadron bootstrap model was an attempt to explain the zoo of subatomic particles without relying on the idea of fundamental building blocks.
Because the prevailing theory was always reductionism. If you smash a proton hard enough, you'll find the smaller, solid blocks inside it, like quarks.
Just breaking things into smaller things.
Exactly. But the bootstrap model proposed something radical. There are no fundamental building blocks. Every subatomic particle is dynamically composed of the interactions of all the other particles.
It's a system of self-consistency. A proton isn't made of smaller things. A proton is a dynamic probability pattern generated by the exchange of other particles, and those particles are generated by the exchange of protons.
It's all circular.
Every particle theoretically contains and helps generate all the others. Capra literally called Indra's net the first bootstrap model of reality.
But theoretical physics didn't stop in the 1970s. The sources we are analyzing today push past Capra's philosophy into incredibly rigorous mathematics, specifically a field known as relational quantum dynamics, or RQD.
RQD is where my brain starts to legitimately ache because it takes the metaphor of the reflecting jewels and turns it into testable algebra.
It's heavy math.
Very heavy. RQD proposes that the foundational fabric of reality is an entanglement network, a vast web of quantum information. And to mathematically model this web, physicists use something called an awareness metric.
It's important to clarify right away that awareness in this mathematical context does not mean biological consciousness or sentient thought.
It's not a brain.
No, not at all. It is a precise metric combining two concepts from information theory: quantum mutual information and integrated information.
Let's break those down. What exactly is quantum mutual information?
In quantum mechanics, mutual information is a measure of correlation. It uses von Neumann entropy to calculate how much knowledge one subsystem essentially possesses about another subsystem. If two systems are deeply entangled, their mutual information is extremely high. Measuring one gives you a massive amount of information about the other.
So mathematically, quantum mutual information is the literal equivalent of the reflections in the jewels of Indra's net. The clearer the reflection, the higher the mutual information.
Exactly. And the second half of the metric is integrated information, derived from Giulio Ternoni's integrated information theory.
Which was for neuroscience originally, right?
Yes. Originally developed for neuroscience, IIT measures how holistic a system is. How much the system's total information is strictly greater than the sum of its independent parts. When applied to RQD, it measures how deeply a localized cluster of quantum relations functions as a unified whole.
Okay, so RQD uses these metrics to map out the relational distance between quantum systems. The higher the entanglement, the more mutual information they share, and the closer they are in the relational network.
Which leads to the most profound paradigm shift in modern physics. If relational distance is determined strictly by the density of entanglement, then the space separating objects is not fundamental.
Space-time itself is an emergent property.
Yes.
I really struggle to accept that. I mean, I understand the math, but experientially, if I trip over a curb and fall on my face, gravity feels incredibly absolute.
Oh, definitely. Concrete hurts.
Yeah. The concrete hitting my face does not feel like an emergent illusion generated by an information network. It feels like a physical force operating in a physical container called space.
Your pushback makes perfect sense from a macroscopic evolutionary perspective. But think about temperature. When you touch a hot stove, the heat feels like a fundamental absolute property.
Right.
But physics tells us temperature doesn't actually exist at the fundamental level. It is an emergent illusion created by the average kinetic movement of billions of individual molecules.
So space is like temperature.
Yes. Space-time is not an empty stage where particles are placed.
Yeah.
The entanglement network generates the geometry of space.
Mind blown.
The distance between you and the concrete is just a measurement of the relational entanglement between your atoms and the atoms of the ground. And the sources suggest that gravity, the curvature of space-time that pulls you down, is simply a localized region where the relational interdependence is intensely concentrated.
So massive objects don't warp an empty spatial grid. Massive objects are just highly dense clusters of quantum mutual information.
Exactly.
So space doesn't separate us. Space is simply the visible manifestation of how we are connected. That is beautiful. But if everything is a localized node in an instantaneous entanglement network, it forces us to address a massive glaring contradiction.
The cosmic speed limit.
Exactly, the Reddit debate. If the universe is fundamentally non-local and alpha reacts to beta instantly across millions of light years, why can't I build an entanglement-powered telephone and call a colony on Mars with zero latency?
Right. Why no FTL internet?
If the connection is real, why can't we use it?
This is perhaps the most heavily debated, wildly misunderstood aspect of quantum mechanics. When people first grasp that separation is an illusion, their immediate assumption is that we can hack the system to bypass the speed of light.
We saw this entire debate unfold in the Reddit sources from the Ask Physics community. The users there are incredibly sharp, but you could read the genuine frustration in their posts.
Oh, they get so mad.
One user practically demanded an answer. They said, if Alice measuring alpha instantly collapses Bob's particle on the other side of the galaxy, how is that not the transmission of information faster than light?
And the physicists in the thread continually pointed back to a fundamental mathematical proof in quantum information theory known as the no communication theorem. It's also sometimes referred to as the no signaling principle.
Let's unpack the actual mechanics of the no communication theorem because it explains how the universe protects causality while allowing for instantaneous connection.
Let's return to Alice on Earth and Bob on Mars. They share a pair of entangled photons. Alice wants to send Bob a binary message, a 1 to signal attack or a 0 to signal retreat.
Like Morse code.
Right. She decides she will measure her photon to collapse Bob's photon into a specific state, effectively sending the signal.
But the mechanism immediately fails because of the inherent probabilistic nature of quantum mechanics. Alice cannot choose whether her detector registers a vertical spin, which is a 1, or a horizontal spin, a 0. The collapse of the wave function is entirely random.
Precisely. To send information, you must have control over the encoding. If you are sending Morse code with a flashlight, you have to decide when the light turns on and off. But measuring an entangled particle is like flipping a quantum coin. Alice gets a completely random string of heads and tails.
Because Alice's results are random, Bob's instantaneous results are also random. Bob sits on Mars looking at his detector, and all he sees is static. A random sequence of ones and noise. He has absolutely no way of knowing if his particle collapsed randomly due to environmental noise, or if it collapsed because Alice measured her half of the pair.
To understand why Bob is blind to Alice's actions, we have to look at the math of the local density matrix.
What exactly is a density matrix in this context?
In quantum mechanics, a density matrix is a mathematical tool used to describe the statistical state of a system when we don't have complete information about it. It maps out the probabilities of all possible measurement outcomes.
Okay.
Because Bob only has access to his half of the entangled pair, physicists calculate his reality using a reduced density matrix, which traces out or ignores Alice's half.
So Bob's density matrix is basically a master spreadsheet of the probabilities of what his particle will do.
Right. And the no communication theorem mathematically proves that whether Alice measures her particle or throws it in a black hole or does absolutely nothing, Bob's reduced density matrix does not change.
It stays identical.
The statistical probabilities of his isolated subsystem remain entirely identical. From his local perspective, nothing has happened.
There was a common analogy brought up in the Reddit threads to explain this limitation. A user brought up the mismatched socks analogy.
The classical correlation argument.
Right. It goes like this. You have a pair of socks, one red and one blue. You blindly put one in a box and give it to Alice on Earth, and you give the other box to Bob, who flies to Mars.
Classic setup.
Alice opens her box, sees a red sock, and instantaneously knows with 100% certainty that Bob has a blue sock. No information traveled faster than light to turn Bob's sock blue. It was simply a pre-existing correlation. You can't use the socks to send a message.
It is a very comforting analogy because it relies on classical logic. But as we discussed with Bell's theorem in the cosmic casino, it is fundamentally flawed.
Why does it fail?
Entanglement is not a pre-existing correlation. The socks are not red or blue while in the boxes. They are in superposition. The universe dynamically decides their colors at the exact moment Alice opens her box.
So even though the correlation is dynamically generated across space in real time, the randomness of the generation prevents it from being weaponized as a communication tool.
Yes, exactly.
The only way Bob can ever verify that his particles are entangled with Alice's is if Alice picks up a traditional classical radio and transmits a message at the speed of light saying, "I got a red sock." Bob looks at his data, sees he got a blue sock at the exact same timestamp, and confirms the entanglement.
This is the universe's ultimate compromise. It allows the fundamental layer of reality to be a singular, non-local, deeply intertwined web, Indra's net, but it enforces a strict local speed limit on the transmission of usable information.
To protect the timeline.
Yes, it preserves cause and effect in the macroscopic world, preventing temporal paradoxes while maintaining a causal harmony beneath the surface.
A causal harmony is a brilliant phrase. It brings us perfectly to the next critical phase of our deep dive.
Let's get into it.
If this connection between alpha and beta isn't a mechanical cause and effect signal traveling through space, what is it? Physics can describe the math of non-locality, but to understand the nature of a causal relationships, we have to look beyond the particle accelerators. We have to look at the architecture of the human mind.
When you realize that the physical universe operates on a causal relational connections, it forces a radical reevaluation of psychology and human consciousness.
It really does.
And the blueprint for this intersection was drawn up by two of the most brilliant minds of the 20th century, the quantum physicist Wolfgang Pauli and the pioneering psychoanalyst Carl Jung.
The collaboration between Pauli and Jung is one of the most fascinating intellectual crossovers in history. In the early 1930s, Wolfgang Pauli was at the absolute zenith of his career.
He was a rock star in physics.
He had formulated the Pauli exclusion principle, which dictates the structure of matter, and he would later win the Nobel Prize. But his internal life was catastrophic.
Pauli was experiencing a profound psychological breakdown. His mother had taken her own life, his brief marriage ended in a disastrous divorce, and he was self-medicating heavily with alcohol. He was fundamentally unmoored.
So he sought help.
Yes. Seeking a way out of the chaos, he contacted Carl Jung for analytical therapy.
Jung was fascinated by the unconscious mind and how it communicates through deep archetypal symbols and dreams. And Pauli turned out to be the ultimate case study.
A perfect patient.
Here was a rigidly logical, theoretical physicist who was producing incredibly vivid, highly mathematical, and mythological dream imagery. Over the course of their relationship, Jung analyzed hundreds of Pauli's dreams.
What started as therapy evolved into a profound intellectual partnership. Pauli began teaching Jung about the strange paradoxes of quantum mechanics, specifically the concept of complementarity.
What's that?
It's the idea that a particle can act as a wave or a point of matter depending on how you measure it, but never both simultaneously.
And Jung realized that this quantum complementarity mapped perfectly onto the structure of the human psyche. The conscious mind and the unconscious mind act like complementary quantum states.
Exactly. But their most significant breakthrough came when they tried to reconcile the non-local entanglement of particles with the bizarre, seemingly impossible coincidences that occur in human life. Together, they formulated the concept of synchronicity.
Jung defined synchronicity as a causal connecting principle. He argued that just as particles can be deeply correlated without a mechanical force passing between them, an internal psychological state, like a vivid dream or an intense emotional realization, can be meaningfully correlated with an external physical event.
Without any direct cause and effect mechanism linking the two.
To ground this, we should look at the specific mechanism Jung used to explain it. He believed that the collective unconscious, the deep, shared structural layer of the human mind, and the physical universe are not two separate things.
They're one.
They are two expressions of the same underlying unitary reality, which he called the unus mundus.
One world.
Yes. When a synchronicity occurs, it isn't the mind magically projecting a force to alter physical reality, nor is the physical world causing the mental state. Instead, an underlying node in the unus mundus dynamically actualizes in both realms simultaneously.
It is the psychological equivalent of Bell's theorem.
Yeah.
Two seemingly separate events are revealed to be a single, dynamically correlated phenomenon.
The classic famous example Jung recorded involved a deeply rigid, overly rational patient. She was practically impervious to therapy because she analyzed everything to death. One day, she was recounting a profound dream where someone handed her a piece of jewelry shaped like a golden scarab.
The scarab, of course, being one of the oldest mythological symbols for rebirth and transformation.
Right. And at the exact moment she is describing this mythological insect, Jung hears a frantic tapping at his window. He turns, opens the glass, and a large insect flies into the room.
What are the odds?
He catches it in his hand. It is a rose chafer beetle, the closest living equivalent to a golden scarab found in Europe. He hands it to the stunned patient and says, "Here is your scarab."
That event shattered the patient's rigid Cartesian worldview. There was absolutely no local, mechanical cause and effect chain that led her unconscious mind to dream of a scarab at the exact coordinate in time that a rare beetle decided to fly against that specific window pane.
It wasn't a causal correlation. The psychological reflection and the physical reflection matched perfectly, demonstrating that the mind and matter are just different facets of the same jewel in Indra's net.
And this idea that reality has a hidden underlying layer that projects these correlations was mathematically formalized by another legendary physicist, David Bohm.
Bohm's work is incredible.
Bohm was a protege of Einstein, and he was deeply dissatisfied with the Copenhagen interpretation, which just accepted randomness without explaining the underlying ontology.
Bohm wanted to know the mechanics of the unus mundus. How does the universe actually store and project these non-local connections?
Bohm developed a framework based on pilot wave theory, which he eventually expanded into the concept of the implicate and explicate order. He argued that the universe we perceive, the physical world of isolated objects, distinct particles, and separate human bodies in space, is the explicate order. It is unfolded, explicit, and measurable.
But this explicate reality is entirely superficial. It is constantly emerging from and dissolving back into a deeper, hidden, undivided wholeness, the implicate or enfolded order.
To explain the mechanics of how the implicate order functions, Bohm used an incredibly elegant analogy involving a fluid dynamics experiment. Imagine a specialized laboratory device. Two concentric glass cylinders with a small gap between them, and that gap is filled with highly viscous, perfectly clear glycerin.
Okay, so a clear, thick liquid between two glass tubes. You take a single distinct drop of black ink and you inject it directly into the clear glycerin. It sits there as a discrete, isolated object, an explicate thing.
Now, you attach a motor to the inner cylinder and slowly begin to turn it. Because the glycerin is so thick, it doesn't splash, it shears. The drop of ink gets stretched out, drawn into a microscopic, infinitely thin thread until it completely disappears from view. The glycerin looks perfectly clear again.
A classical physicist would say the ink drop has been destroyed or randomly dissipated, but Bohm says the ink hasn't vanished. The order, the information of that specific drop, has been enfolded into the entire volume of the glycerin. It has become implicate.
And the absolute genius of the mechanism is this. If you reverse the motor and turn the cylinder backward the exact same number of rotations, the microscopic threads recoalesce. The perfectly formed drop of ink suddenly reappears out of nowhere. It unfolds back into the explicate order.
Now, Bohm takes it a step further to explain the illusion of motion and separation. Imagine you put in a drop of ink, turn the cylinder 10 times so it vanishes. You inject a second drop in a slightly different spot, turn it 10 times. You inject a third drop, turn it 10 times.
This is where it gets crazy.
When you finally reverse the spin, you see a stunning illusion. Drop 1 appears and vanishes, then drop 2 appears and vanishes, then drop 3. To an observer watching this, it looks like a single solid particle is moving across the liquid in a straight line.
But nothing is moving.
Huh?
It is just different drops continuously unfolding and unfolding. So what does this all mean when applied to quantum mechanics?
Good question. What does it mean?
It means that when we observe a subatomic particle moving through space, or when we measure two entangled particles separated by a massive distance, we are only interacting with the explicate projection. We think they're separate objects, but in the implicate order, through the non-local pilot wave, they are intimately connected.
They are the hidden ink.
Yes, they're just the invisible ink smeared across the cosmic glycerin. Isolated particles and isolated people are localized projections of a singular, undivided wholeness.
This maps so flawlessly onto Indra's net that it's almost terrifying. But what's even more fascinating is that we aren't just using these ancient concepts to understand abstract physics or historical psychology anymore. The sources highlight that we are actively using the architecture of Indra's net to build alien intelligence.
You are referring to the 2025 research on the Indra representation hypothesis in artificial intelligence.
Yes. When computer scientists analyze the internal architecture of massive large language models, the foundation models driving the AI revolution, they are finding emergent structures that defy classical localized programming.
Let's unpack the mechanics of a neural network's latent space to understand this. When an AI processes human knowledge, it doesn't store a dictionary definition of a word like apple in an isolated folder. It maps concepts into a high-dimensional mathematical space.
Every single concept, every word, every idea is assigned a coordinate, a vector in a space that can have tens of thousands of dimensions.
And the critical realization is that a vector has no inherent meaning in isolation. The AI understands what an apple is exclusively by calculating its geometric distance and relational angle to the vector for red, the vector for fruit, the vector for gravity, and millions of other concepts.
It is entirely relational. The AI researchers proposing the Indra representation hypothesis noted that as these models scale up, they spontaneously organize their latent space into a holistic web, where every single data point derives its identity solely from its relative position to every other data point.
They are organically replicating the architecture of Indra's net inside silicon. The AI doesn't understand facts, it understands the holographic geometry of relationships.
It strongly implies that the fundamental architecture of intelligence, whether it is artificial, human, or cosmic, is an interdependent web. The isolation of data, just like the isolation of particles, is an illusion that prevents true understanding.
Which brings us to a point of synthesis for this entire journey. We have traversed a massive intellectual landscape today.
We started thousands of years ago in the Vedic traditions, watching a divine weapon of war transform into Mahayana Buddhism's ultimate vision of reality, a cosmic net of infinite jewels entirely empty of inherent self, existing only as reflections of the whole.
We then track the disintegration of the classical Newtonian worldview, mechanically unpacking how Bell's theorem in the cosmic casino proved that local realism is mathematically false. Entanglement demonstrates that particles are not separate things, but non-local relationships.
We looked at the dense math of relational quantum dynamics, exploring how quantum mutual information and integrated information metrics suggest that spacetime itself, the very gravity pulling us to the floor, is an emergent illusion generated by the density of the entanglement network.
We navigated the no-communication theorem, recognizing that while the universe is deeply interconnected, the randomness of quantum collapse protects the causal flow of time, preventing us from sending faster-than-light signals.
And finally, we moved beyond the physics laboratory into the human psyche. We saw how Jung's synchronicity and Bohm's implicate order describe a reality where the mind and the physical world are just different explicate unfoldings of a singular, hidden wholeness. An architecture we are now watching emerge in the latent space of artificial intelligence.
This raises an important question, and it is the question I want every listener to confront directly. If the bleeding edge of theoretical physics, the deepest psychoanalytic theories, and the most ancient spiritual texts all completely agree that reality is a web of mutual definition, If there are literally no isolated objects in the universe, how does that alter the way you navigate your daily life?
It changes everything.
Your biological form, your conscious thoughts, the history you inherit, and the actions you take do not occur in a vacuum. They are intimately, mathematically, and philosophically entangled with the entirety of the cosmos. The loneliness and isolation that define so much of the modern human experience are, at the most fundamental level of physics, a measurable illusion.
You are not a separate spectator looking out at the universe through a window. You are the universe actively expressing itself at a specific set of coordinates. And I want to leave you with one final, deeply provocative thought to explore on your own. We have established that space and distance are emergent illusions generated by quantum relationships. We know that the neural networks in our own brains operate on complex, interdependent, relational webs that perfectly mirror the latent space of AI and the ancient vision of Indra's net. So consider this. Is consciousness actually a local phenomenon? Is your awareness truly being generated by chemical reactions trapped inside the dark, isolated bone of your skull? Or is consciousness simply the fundamental intrinsic property of the connective webbing of the universe itself? Are we, in the truest sense of the metaphor, just the universe looking back at its own brilliant reflection in a single polished jewel?
It is a paradigm-shifting question, and one the physics community is only just beginning to grapple with.
Next time you walk outside and look at a tree, don't just see the wood and the leaves. See the sunlight, the gravity, and the deep invisible connections that hold it all together. See the net. Thank you for joining us on this deep dive. Keep questioning the boundaries of reality, keep connecting the dots, and keep exploring.